Hi, my name's Kyle D. Evans. I am a maths-based entertainer, sometimes maths singer, though I'm not going to be doing any singing today, not really. What I'm going to do today to start you off with, as a warm-up, I do this at the start of all of my shows. I've heard that all the people out there watching this are going to be aged 7 to 11. So what I would like you to do is to take your age. There's probably different people in the room with you of different ages, so this is going to work out differently for all of you. But what I'd like you to do is take your age, and I want you to do the following. If your age is an even number, I want you to halve it. If your age is an odd number, I want you to triple it and add 1. This will take you to a new number. That new number will be odd or even. And if your new number is even, you halve it again. If your number's odd, you can't halve it, not to end up with a whole number anyway, so you triple it and add 1. Half or triple plus 1. Well, whichever number you're on, you're half or you triple plus 1. Sometimes these are called HOPTO numbers. I quite like that because you either half or you triple plus 1. Keep doing that until you decide to stop. See what happens. See what happens for other people in your class. Maybe you might want to find out what happens for your teacher, if you're allowed to know how old they are. Maybe give this a pause now. Share your ideas, find out what happens amongst yourselves, and come back here and I'm going to talk a little bit more about the potential outcomes. Hello again. So I wonder what happened. I wonder if there's any 7-year-olds. Now, I've got to say, this is a little bit hard for 7-year-olds, but maybe you got a bit of help. Because if you're 7, you can't halve that 7 not to end up on a whole number, so you have to triple 7 and add 1. So 7 goes to, triple it is 21 plus 1 is 22. You can halve 22, so 22 goes to 11, but you can't halve 11, that needs to be tripled. 11 goes to 33, goes to 34. 34 is even, so we can halve it. Well, half of 30 is 15, half of 4 is 2, 15 and 2, 17. 17's not even. We've got a triple plus 1. Goodness me, 3 17s. Well, 3 10s is 30. 3 7s we just did is 21. So that's 51 we're now on. Plus 1 is 52. Wow. Now we can halve. 52 goes to 26. We can halve again. 26 goes to 13. 13, unfortunately, is odd, so we have to triple it and add 1. Well, 13 goes to 39 plus 1 is 40. 40 halves to 20, 20 halves to 10, 10 halves to 5. Is this ever going to end or stop? 5, we have to triple and plus 1. 5 goes to 15, 16. Halve it is 8, halve it is 4, halve it is 2, halve it is 1. Phew! But do we stop there? 1's an odd number. Maybe you didn't stop there. Maybe you tripled it and added 1, which takes you to 4. 4 goes to 2, 2 goes to 1. Triple it and add 1 takes you to 4. 4 goes to 2, 2 goes to 1. Where's this going to end? Well, maybe it does end there. It's always going to get into a loop there, isn't it? If you were just 1 year older, 7-year-olds, if you were 8, it goes like this. 8 goes to 4, 4 goes to 2, 2 goes to 1. Goes to 4, goes to 2, goes to 1, goes to 4, goes to 2, goes to 1. Well, that's quite a lot easier for 8-year-olds, isn't it? How about if you're 9? Right, 9 is odd, so we need to triple it and add 1. 9, 18, 27, plus 1 is 28. Half that is 14, half that is 7. Hang on a minute, we're on 7. 7, triple it and add 1 is 22. We've done all these steps. We've done all these steps already. Our chain for 9-year-olds has now matched up with that whole chain I just went through for 7-year-olds. So 9-year-olds, we know that that would end up getting to the 4, 2, 1 loop. 10-year-olds goes 10, halve it is 5. Triple it and add 1 is 16. We did all this earlier as well. 16 halves to 8, halves to 4, halves to 2, halves to 1, and we're in the 4, 2, 1 loop. How about 11-year-olds? 11 triple it and add 1 goes to 34. I'm sure we've had this. Half of that is 17. Triple 17 is 51. We had all this stuff here. We've done all of this as well. For 11-year-olds, no matter how old you are, it seems that you'll get into the same loop. Maybe you'd like to pause me now and try any other numbers that you'd like to. We've tried 7 to 11. What other numbers could you try? Can you find anything that doesn't get into the 4, 2, 1 loop? You might want to pause me before you go on any further. What did you get? Did anyone find anything that doesn't get into the 4, 2, 1 loop? Now, I hope you didn't, because no one in the history of mathematics has ever found a number that doesn't get into the 4, 2, 1 loop. Some numbers take a long, long time. I think the worst one is 27, or the worst one between 1 and 100 is 27, which takes over 100 steps. It bounces up way into the 500,000s, I think, off the top of my head. But it still eventually comes down to the 421, 421, 421 loop. Amazing. But just because we haven't found anything yet that doesn't mean that every number gets there. And this is something I love about mathematics. Even though it's such a simple rule, no one in the whole world has been able to prove that every single number ends up in that 421, 421, 421 loop. And certainly you can't test all the numbers because there's infinitely many numbers to test. We need some other clever way, and no one on earth has come up with that clever way. Hey, if you continue your studies in mathematics, maybe you could be the person that comes up with that breakthrough. The best of luck to you in trying. It's called the Collatz conjecture, by the way, and it's a conjecture because no one's proven it yet. Does everything, every number, if you halve or triple and plus 1, end up in the 421 loop? Over to you.